Linac technologies.
Hello and welcome back to Simac Demos, where we show you how to use Simac to learn and troubleshoot linacs. Today we will use Simac to investigate and replicate beam peaking. Let's imagine the electron gun properties have changed due to aging, maintenance, replacement, or some other reason. To simulate this scenario, let's set the gun grid voltage to an arbitrary value, say, 100 volts. Let's record the dose rate, 190 centigrade per minute. We see that when the electron gun grid voltage has changed, the dose rate has decreased to 107 centigrade per minute. This is because the beam energy has increased, and now it does not match the bending magnet pass-through energy. To fix this mismatch, we need to reduce the beam energy. To understand how this can be done, let's go to the modulator section. The reduction in the beam energy can be achieved by reducing the power produced by the klystron, which, in turn, can be controlled by changing the dq fraction. Let's reduce the dq fraction to 1.44 and see what happens. Too much reduction in energy. Let's try 1.442. Increasing the dq fraction to 1.4425 should be enough. Let's try. Perfect, the accelerated beam passes through the bending magnet. The dose rate has reached its peak. Just to check, let's increase the dq fraction and see what happens to the dose rate. The dose rate drops from 179 centigrade per minute to 171, so previously we were at the peak dose rate. Now we know how beam peaking works. See you at the next one.